Hello, very good morning students. Myself Ekal Shah from New LG Institute of Engineering and Technology. Today we are going to discuss the subject probability and statistics, and today's our topic of the discussion is the studying the solving the method of correlation, and today we are going to discuss the mathematical method, and that is Carl Pearson's coefficient of correlations. So in this method, the coefficient of the correlation is measured of the correlation between the two random variables x and y, and it is denoted by r, small r is equal to COV. COV is the covariance, and this xy, so it is here, this COV xy is the covariance of the variable x and y. And this sigma x and sigma x is the standard deviation of variable x, and sigma y is the standard deviation of variable y. This expression is known as Carl Pearson's coefficient of correlations. So Carl Pearson's product moment coefficient of correlation, that is also described by R equal to summation x minus x bar y minus y bar upon square root of summation x minus x bar whole square, and in the other square root summation y minus y by whole square. It is also described by summation xy minus summation x into summation y whole by n upon square root of summation x square minus summation x whole square by n, and other square root, it is just like this, right? And this is the other square root, students. This is summation y square minus summation y whole square upon n. Carl Pearson's coefficient of correlations. So the properties of these correlations of coefficient of correlation, that is, it is lies between -1 to 1. Correlation coefficient is independent of change of origin and change of square, and two independent variables are uncorrelated. Let's start some example for the better understanding. And our first question is calculate the correlation coefficients between x and y using following data. Okay, here we want to calculate correlation coefficient. This is our given data x and y. Here x is 2, 4, 5, 6, 8 and 11. And the corresponding y is 18, 12, 10, 8, 7 and 5. So for solving this example, here we have total 6 values, right? 1, 2, 3, 4, 5, 6. So here n equal to 6. What is our x? That is 2, 4, 5, 6, 8 and 11. And what about y? 18, 12, 10, 8, 7, 5. First, we calculate the x square, and that is 4, right? 16. What about the square of 5? That is 25. Here 36, 84 and 1, 2, 1, 121. Similarly, the square of y, and that is square of 18, that is 3, 2, 4, 12, that is 144. Square of 10 is 100. This is 64. Square of 7, that is 49. And the last, that is 25. In the last column, we want to find the product of x and y. So 18 twos are, and that is 36. Here 12 fours are 48. 10 fives are 50. 6 eights are 48. 8 sevens are 56. And the last 11 fives are, that is 55. Okay. And in the last row, we want to find out the summation of x, and that is the summation of all these value, that is 36. Here summation of y, and that is 60. Here summation of x square is 266. Summation of y square is equal to 706. And the last summation of xy, it is 293. Okay. Now we want to find the correlation coefficient between x and y. That's why we are going to use this formula, this one. We are going to apply the Pearson's coefficient of correlation, right? That's why we are going to apply this formula. Okay. And that is R equal to summation xy minus summation x summation y whole by n whole divided by square root of summation x square minus summation x whole square upon n, and in the other square root, this is summation y square, right? And minus summation y whole square upon n. Now, if I substitute the value in this case, 293 minus 36, summation y is what? That is 60 upon 6, n is 6 upon square root of summation x whole square, and that is 36 sorry, summation here summation of x square, and that is 266, and summation y square is 706, right? So it is 266 minus this one is 36 whole square upon n is 6, and in the other square root, this one is 706 minus 60 whole square upon 6. Okay. After simplification is equal to, it is minus 0.9203. So this is the correlation coefficient between the given x and y. Here we have used the Pearson's correlation coefficient method. For the other example, calculate the correlation coefficient between x and y using the following data, and that is x equal to 5, 9, 13, 17, 21, and related y is 12, 20, 25, 33, and 35. Here your n is 5. Here we are using the other method. That's why we take x bar, and that is summation of x upon n. Here summation of x, that is 65 students. Here 5 plus 9 plus 13 plus 17 and 21, that is 65 upon 5. So x bar is 13. And the similar way, y bar, that is summation of y upon n, it is equal to 125 upon 5 is equal to 25. Here we can take x, y, then x minus x bar. The next column we can take y minus y bar, right? Here x minus x bar whole square. This is y minus y bar whole square. And in the last column, x minus x bar into y minus y bar. Okay. So what is our x? X is 5, 9, 13, 17, and 21. What about y? That is 12, 20, 25, 33, and 35. X minus x bar, x is 5, x bar is 13. So x minus x bar is minus 8, then minus 4, here 0, 13 minus 13 is 0, then 4 and 8. Y minus y bar, that is 12 minus 13, right? So that is 12 minus 25, and that is minus 13. Next one is minus 5, then 0, 8, and 10. Here, x minus x bar whole square. So this is 64, here 16, this is 0, again 16, and 64. And the same way, y minus y by whole square, that is 169, 25, 0, 64, and 100. And in the last column, we want the multiplication of x minus x bar into y minus y bar. So 13 8s are, and that is 104, right? Here, minus 4 into minus 5, so 20, 0 into 0 is 0, 8 4s are 32, and 8 10s are, that is 80. In the last row, we'll do the summation of all column, that is summation of x, and it is, as you all know, it is 65, summation of y, and that is 125, right? Here, summation of x minus x bar, here 0, and summation of y minus y bar is equal to, this is 13 plus 5, and that is 18 minus 18 plus 18, it is also 0, right? Here, summation of x minus x bar whole square, and is equal to 180. This is 160. Okay. And summation of y minus y bar whole square, it is 358. And last, summation of x minus x bar and y minus y bar is equal to 236. So this is our table which we want to apply in this formula, and that is R equal to summation x minus x bar into y minus y bar whole divided by in the square root of summation x minus x bar whole square in the other square root summation y minus y bar whole square. Okay, so if I apply the formula value, it is 236 upon square root of 160, and in the other square root it is 358, right? So after simplification, my final answer is 0.986. This is the another Carl Pearson's formula for solving or for calculating the correlation coefficient between the given data x and y, right? Let's move with one more example for the better understanding, and that is calculate the correlation coefficient between x and y using the following data. Here, your x is 17, 19, 21, 26, 20, 28, 26, and 27. And the related y is 23, 27, 25, 26, 27, 25, 30 and 33. Okay. So for solving this kind of example, here we assume A, and that is let A equal to 23. We can take A randomly from the given data and B equal to 27. It is assumed means of X and Y series respectively. Got it? It is assumed by means of X and Y series respectively. So dx is equal to x minus a, that is x minus 23. And what about dy? dy is equal to y minus b, that is y minus 27. And here n equal to 8, right? See, you can check 1, 2, 3, 4, 5, 6, 7 and 8. So let's write down the value of x, that is 17, 19, 21, 26, 20, 28, 26 and 27. And related y is 23, 27, 25, 26, 27, 25, 30 and 33. Now what about dx? So dx is x minus 23, right? And your x is 17. So it is minus 6, it is minus 4, minus 2. This one is 26 minus 23, so that is positive 3. Here negative 3. Next one is 5. 26 minus 23, so again this is positive 3. And last one, that is 4. Similarly for dy, that is y minus b, so y minus 27, and y is 23 minus 27, so minus 4. This one is 0, minus 2, minus 1, 0. This one is minus 2, 3, and last 33 minus 27, that is 6. Here dx square, so 36, 16, 4, 9, again 9, 25, 9 and 16. dy square, so 16, 0, 4, 1, 0, 4, 9, and this is 36. What about dx into dy? So that is 24, minus 4 into 0 is 0, 4, minus 3, 0, minus 10, 9, and last one 6 4s are 24. In the last row, we want the summation of, this one is the summation of dx, and that is 0. Summation of dy, that is also 0. Summation of dx square, and that is 1, 2, 4. Summation of dy square, and it is 70. And last one, summation of dx dy, that is 48. Now we'll apply all these value in the Pearson's another method, and that is r equal to summation of dx dy minus summation of dx, this one is summation of dy upon n, and whole by in the square root of summation of dx square minus summation of dx whole square upon n, and in the other square root summation of dy square minus summation of dy whole square upon n. So if we apply value from the table, that is summation of dx dy is 48 minus 0 upon this is 124 minus 0, and in the other bracket that is 70 minus 0. So after simplification, we'll get 0.515. Got it, students? So these are the different three method. Method is same, Carl Pearson's, but we have applied different three formula according to given data for solving coefficient of correlation. Okay. So feel free to contact me for any query. Till that, enjoy the. Feel free to contact me for any query. Students, feel free to contact me for any query. Till that, enjoy the study. Thank you.